Hello, this is a video on how to solve one-step equation with addition and subtraction. So in in our number routine, it says represent 5 using at least 9 tiles. So 1, 2, 3, 4, 5. But I have to represent this with at least 9 tiles. Is this 0 pair? So that means 0. So it still represents 5, even though I added these two, added a 1 and a -1. So I put this to this, this to this, and I still have 5. 5 plus 3 plus -3. The 3 and -3 becomes 0 pair, and I still have 5. And I did represent it with 8, 9, 10, 11 tiles. Nice. So this is a equation mat. In this equation mat, this side will equal this side. Think of it as a balance beam, or think of it as a scale as you see in 6th grade science. So in this scale, let's pretend, if this side weighs 3 pounds to make it balanced, then this side has to also weigh 3 pounds. What if I added 2 pounds to the right-hand side? Will it be balanced still? No. I then have to add 2 pounds to the left-hand side. What if I added -2 to the right-hand side? Will it be balanced? No. These will cancel out. So are they balanced? So I need to add 2 negatives. So these cancel out, and now it is balanced. So in an equation, both sides need to be equal to each other. Whatever you do on the left side, you need to do on the right side. Whatever you do on the right side, you need to do on the left side. So for example, we have our problem here. We have x plus -4 equals 2. In order to solve an equation, you have to isolate the variable. So we need to isolate this variable x. This needs to be by itself. In order to make this by itself, we need to get rid of these -4. So you do the inverse operation. So what is the inverse of -4 or -4? +4. But because I added 4 to the left side of the equation, is it balanced now? No. I need to balance it, so I need to add 4 to the right-hand side equation. These cancel, these cancel, these cancel, these cancel. So x is equal to 1, 2, 3, 4, 5, and 6. So we just did this example. So now let's try to do it without using algebra tiles, but through drawing. Let me get my calligraphy pen. Oh, wait. So I have x and -4 is equal to 2. So I need to isolate the variable x by adding the necessary tiles to each side. Write the equation to the right and check your work. So the equation is x, 1, 2, 3, goes -4 equals 2. So I need to isolate the variable x. So I do the inverse of -4 with +4. But is it balanced? No. I need to draw it on this side. These all disappear, 0 pair. So I have x equal 6. And it does say check your work. So I replace the x with 6. 6 minus 4 equals 2. Is that true? Check mark. 6 minus 4 is 2. It is equal to 2. All right, next example. So we have an x. We have a +2 equals 1, -6. How can I isolate this x right here? I need to get rid of +2. What's the inverse of +2? minus 2. Balance it out, please, with the right side, minus 2. These cancel out, so x is equal to negative 1, 2, 3, 4, 5, 6, negative 8. Let's try to do it with drawing. So let's write the equation. We have x plus 2 equals negative 6. Now solve it. I need to isolate this x. In order to isolate, I need to do the inverse of plus 2. So minus 2, minus 2. Make sure you balance it with the other side. This disappear. So x equals negative 8. Let's check our work. Negative 8 plus 2 is negative 6. Check mark. That is true. Next example. I see negative 3 is equal to 2 plus an x. I need to isolate this variable x, so I need to do the inverse of plus 2. So it's minus 2. Balance it with the other side. This cancel, 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 cancel. So x equal negative 5. Let's do it by drawing. So let's write the equation. I see negative 3 equal 2 plus an x. So how do I isolate this x right here? I need to do the inverse. So I need to draw minus 2, balance it with the other side. So these cancel, or zero pair. So negative 5 equal x, or x equals negative 5. Let's check our work. Negative 3 equal 2 plus negative 5. Is 2 plus negative 5 equal to negative 3? Check mark. It is. Our next example, we have 3 equal 1 plus an x. How do I isolate this x? I need to do the inverse of plus 1, so it's minus 1. Balance it with the other side. This cancel, this cancel. So x equals 2. All right, let's look at our this. Let's write this drawing as an equation. 3 equal 1 plus 1x, or 1 plus x. I need to isolate this x, so I draw the inverse. What's the inverse of 1? Negative 1, negative 1. This goes away. This goes away. So x equals 2. Let's check our work. Is 3 equal 1 plus 2? Yes, it is. All right, let's look at our next example. Oh, number 5 now. Now you're given an equation. Can you draw it? So we have x plus 5. It is equal 9. So I need to isolate this variable, so I need to draw the inverse of 5. So it'll be negative 5. Don't forget to balance out the other side. These become 0 pair. These become 0 pair. So x equal 4. All right, let's check our work. Is 4 plus 5 equal 9? It is. Check mark. Next one, we have a x. Let's draw this, model it. X plus negative 5. Let's draw 5 negatives. Equals negative 2. How can I isolate this x? What's the inverse of negative 5, or minus 5? Plus 5. Plus 5. Do you have any 0 pairs? All of these are 0 pair. These are 0 pair. So what do you have left? X equals 3. Let's check our work. 3 plus negative 5. That adds up to negative 2. Check mark. Number 7, our last example, we have negative 3. It is equal to x plus 8. So how can I isolate this variable x? I need to get rid of these 8. What's the inverse of 8? Negative 8. I don't want a pain thing to draw. So make sure you balance it by drawing -8 on the other side. 4, 5, 6, 7, 8. All of these become zero pairs. So, ooh, that's a lot of negatives. That's -11 equal x, or x equal -11. Let's check our work. Is -3 equal to -11 plus 8? Check mark. It is so. So what we just did were examples of how to model. In our next lesson, we'll actually do it algebraically, model and do it algebraically.